Okay, so in this example, we're asked to integrate the ln function. What is the antiderivative of ln? So initially you might think, oh, wow, what do we do here? How do I handle this? I don't know what to differentiate to be ln. Or maybe you stumbled upon an example problem in the homework problem or something in a class in the past, and you remember, oh, that thing, when I differentiated that thing, I got ln as the answer. Okay. But if not, how do we approach this problem? Right? If we didn't stumble upon it and just memorize some answer, how do we do it? Well, let's try integration by parts. Now remember, in integration by parts, you want u to be one of your parts of the thing, and you want dv to be the other part. It would be not a very good idea to make dv be ln of x dx because, quite simply, I don't know what the integral of ln is. That's what I'm trying to figure out. So I'd have to be able to integrate that to do this problem. So that's not going to work. So, of course, let's let u be ln. And since there's nothing left, that means dv is just equal to dx. And then we remember that the derivative of ln is 1 over x. And, of course, v would just become x. And now we can use our integration by parts formula, and hopefully we'll have something that we can work out. So the process is, once we have it set up, it's uv, so x ln of x, minus the integral of, should that be 1 over x dx, of v du. So x times 1 over x dx. But x times 1 over x is just 1. So we get x ln of x minus the integral of dx, which will give us x ln of x minus, and of course, plus the constant of integration. So it turns out the derivative of the ln is x ln of x minus x. And you can kind of check on that to see that it does work. And you kind of check on that to see that, yeah, that derivative, if you do differentiate this thing, you will get back to just ln. Okay? And so now we have our result. The derivative of ln is actually x ln, or the antiderivative, sorry, of ln of x is just x ln of x minus x. And of course, the indefinite one has a plus a constant. Okay, so not too bad. Pretty direct application here of integration by parts. And in fact, because ln drops us down a degree, 1 over x, when you have integration by parts where the ln is involved, then it's actually the ln and x of powers of x, then you actually want to use u as the ln. It kind of overranks the x in this case. And we're going to see that in our upcoming example.